Good morning, everybody. At least I'm going under the assumption that it's morning. I say good morning to everybody because you never know. It might be morning. I mean, you got a 50-50 shot of it being morning, so good morning. Anyway, today's topic 1.05 scientific notation. This is all about taking very large numbers and very small numbers and compressing them down so that they will fit more easily into your calculator. And it also makes a really quick way of looking at the numbers and comparing them. Shall we begin? Let's do. Now, if you take a look on your calculator, you'll notice that you might have one of these buttons, a button that says EXP, EE, EE as a secondary function, or times 10 to the X. Now, these are exponential notation buttons. EXP, you put your coefficient in, then you hit this button, then you put in your exponent because EXP stands for exponent. EE stands for enter exponent. So you type your coefficient, you push this button, and then you enter the exponent. And then this does exactly the same thing. You put in the coefficient, you push this button, which stands in for times 10 to the, and then you put in the exponent. And that's how you would enter scientific notation into your calculator. You see, calculators will only do exactly what you tell them to do, so you have to speak their language in order to use them properly. Okay, now the format of scientific notation relies on you remembering significant figures because it's similar to the way you've already learned scientific notation with one extra twist. What you do is the coefficient is made of only the significant figures. You put the first significant figure, then a decimal point, and then the rest of your significant figures, times 10 to the number of places back to the ones place after the first significant figure. Now, that may sound a little bit weird, so I'll give you plenty of examples of this. So the front part of it is called the coefficient, and the stuff on top of the times 10 to the, that would be the exponent. So when I use the terms coefficient and exponent, that's what I'm referring to. So first, let's deal with large numbers, numbers that are just too big to put in your calculator. So you have 432, and there's a whole bunch of zeros, microliters. Okay, so how would we convert that into a nice compactified format? Scientific notation allows us to get rid of all these placeholding zeros. There's a lot of stuff, therefore, you won't have to put into your calculator. So what we do is we take all the significant figures, and the significant figures are the 4, the 3, and the 2. There's no line over a 0. There's no decimal point. So there's only these 3 significant figures. Let's pull them out and put a decimal point after the first one. Then we put times 10 to the, and we count how many places after the first sig fig, including the 3 and including the 2 and all the placeholding zeros, how many places after that first sig fig until you get back to the ones place? 16 places times 10 to the 16th. And that's it. That's all there is to it. So here's some more examples. 700. Oh dear, the number just got a lot more complicated. Now notice the line over the 0 here. That indicates that there's 3 significant figures in this number. The rest of this stuff is placeholding zeros. So let's get rid of them. What we do is we pull out the significant figures, we put a decimal point after the first one, and then we count the number of places after that first sig fig to get back to the ones place. And it turns out there's 11 places. So it's times 10 to the 11th. These two zeros make up the first and second of those 11 places. Next example, this is going to be 8 million. Now you could put this number in your calculator, but let's pop this in the scientific notation. There's no decimal point, there's no line over a 0, so there's only one significant figure. So let's pull that out. Now, because there's nothing after it, we don't have to put a decimal point. Yay! Now, there are, after that first significant figure, 6 places to get back to the ones place. Therefore, it's times 10 to the 6th. Now, let's take a large number out of scientific notation. What we do is we take the coefficient, which has all the significant figures. We're going to pull that out and remove the decimal point. Boink. And then we're going to add in enough places after this 7 to get you 10 decimal places back to the ones place. This 3 is going to be the first of those 10 places. So we'll have this 3 as the first place, followed by 9 zeros. And that will give us a total of 10 places to get back to the ones place. All right. Now, again, it's not the number of places after the 3. It's the number of places after the first sig fig. More examples. 1.0 times 10 to the 5th, we pull out the coefficient and we remove the decimal point. There are 5 places after the 1, including that 0, which, by the way, is a significant figure. We got to put a line over it to show it's a significant figure. And then we can add the rest of the zeros to get us back to the ones place. Okay, another example. 4 times 10 to the 4th, easy peasy. You've got 4, and that's all you have. All you need now are 4 places to get you back to the ones place. So that's dealing with large numbers, putting them into and taking them out of scientific notation. Now, what about small numbers? Because there are some seriously microscopic numbers in chemistry, like the mass of an atom, for example. Very, very tiny, tiny numbers. Here's a tiny number. And to convert this into scientific notation, what we do is we take all the significant figures in the measurement, just like we did before, and put a decimal after the first one. So there are 3 significant figures. All these are placeholders. First significant figure, second, and third significant figure. So let's pull those out and put a decimal point after the first one. Now, how many places to get back to the ones place before the first significant figure? In this case, it's actually easier because all I got to do is just count the place-holding zeros, including the 1 in the ones place. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 decimal places to get back to the ones place. So what we do is times 10 to the, since we had to go backwards, -9. 7.02 times 10 to the -9th. More examples. We pull out the significant figures. There's 3 of them. And then we put a decimal point after the first one, times 10 to the, we count the place-holding zeros. 1, 2, 3, 4, 5, 6, 7. 7 places to get back to the ones place. And that's times 10 to the -7th. Okay, how about this? 0.002 microliters. So we pull out the one and only significant figure. All right. And then there's 4 place-holding zeros before that, and therefore times 10 to the -4th. And if you want to take these small numbers out of scientific notation, that's easy. So we remove the significant, we take the significant figures, pull them out, and remove the decimal point. Now, there are 9 places before the 7, including the ones place. So let's put them in. Let's put in 9 zeros, including the 1 in the ones place. See? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 places to get you back to the ones place. More examples. We pull out the coefficient, get rid of the decimal point. There are 5 places to get you back to the ones place. Four times 10 to the -4th, we pull out the coefficient, and we work our way back to the ones place. 4 places. And that is how to put numbers into and take numbers out of scientific notation. Okay? And that is how to put the numbers in your calculator. What you do is you put in the coefficient, push whichever one of these buttons you have. This is basically telling your calculator 10 times 10, and then it's asking you for the exponent, so just put in your exponent. And that's it. So here's how to interpret your calculator. And by the way, this calculator has a times 10 to the x button right down here on the bottom. So For Texas Instruments, 1.0 E5, if your calculator gives you that, it means 1.0 times 10 to the fifth. If it gives you 1.0 E negative 5, that's 1.0 times 10 to the negative fifth. A Sharp or a Casio calculator will give you the exponent off to the side. It'll be like over here on your calculator. So 1.0 times 10 to the negative fifth will be 1.0. Wait a minute, where are we? Oh, here we go. 1.007 means 1.0 times 10 to the seventh. So here's the exponent off to the side. Here's the negative 7. There's the negative 7 exponent. Or you might even have the little times 10 showing up on your calculator. So your calculator, depending on the brand or model, will give you that information. Texas Instruments is pretty much across the board. They use E. It says 1.0 with an exponent of negative 5. That doesn't mean 1.0 to the negative fifth. That means 1.0 times 10 to the negative fifth. All right. That's how you would interpret your calculator. And that's all there is to scientific notation. So, with that in mind, I bid you adieu, adieu. Parting is such sweet, small. Wow, brain and mouth became disconnected. Anyway, have a wonderful day. Bye.